Good morning, everybody, and thank you for joining us. My name is Seth Williams, and I am the counsel for the Fixed Wireless Communications Coalition. And in connection with the National Spectrum Managers Association, we're pleased that everybody can join us this morning for a webinar about the RF evaluation required for Part 101 licensees by the FCC's changes a few years ago to the RF exposure rules. Joining me today is George Kaiser, who is our chief technical consultant for the FWCC. And I'll turn it over to George in just a minute to run through an evaluation that the FWCC has prepared for Part 101 licensees that we believe demonstrates that the vast majority of licensees fall under the general population threshold for RF exposure and are not required to therefore do any further action with regard to RF exposure, and then the remaining Part 101 licensees that do need to take some mitigation or signage steps will also be able to use in order to demonstrate their compliance with the rules. As I think everybody on this call probably knows, the calculations that need to be done by the industry have to be done by May 3rd. And so that is coming up on us. We will make this presentation, a recording of this presentation, available after. So feel free to come back to this presentation or to share it with colleagues or friends in the industry. We also have the underlying analysis that the FWCC has conducted, which we can also make available. Our email addresses will be available at the end of the presentation. Feel free to email me and I can get that information to you. And we will also post that information online so that people can access it from the industry. And hopefully we can all get the sites that we need to have evaluated and be in full compliance with the rules by May 3rd. With that, I will turn it over to George Kaiser to kick off our presentation.
Thanks, Seth. I'm George Kaiser, the chairman of the Fixed Wireless Communications Coalition's Technical Committee. Today, we're going to be talking about the new methodology for RF exposure evaluation for current Part 101 transmitters. Now, keep in mind the current FCC rules apply to all transmitters authorized by the FCC, which includes Part 15 unlicensed transmitters, but we'll be focusing today on the Part 101 transmitters. I assume by now everybody knows you need to put May 3rd on your calendar because that's the day that you should have performed an evaluation according to the FCC's new rules. We'll talk about those here momentarily. Back in 2019, the Commission published a memorandum telling the community that they were changing the criteria for determining whether a licensee is in compliance with the FCC's RF exposure rules. Historically, of course, Part 101 has been exempt, but that changed in 2019. The Commission took the position that all facilities under their jurisdiction must be evaluated. That includes existing licensees as well as new licensees, and that includes all existing transmitters and all new and all future transmitters. They would allow 2 years from the effective date of the ruling for everyone who has a transmitter authorized by the FCC to do an evaluation of those transmitters, and that's where the May 3rd, 2023 date comes from. The final report and order that changed the FCC rules gives you 2 ways of complying with their rules. You can either exempt the transmitter or you can do an evaluation of the transmitter. To do an evaluation of exemption, you have to do an analysis which calculates the distance from the transmitter to any other person that could be nearby the transmitter. Now that's the rub, because in many cases, you may know the transmitter information, you may know your transmit power and antenna size and height above ground level and all those kind of things, but you may not know the terrain and the buildings nearby that transmitter. And that's important because that's what you have to evaluate. What's the distance between the transmitter and where anyone, worst case distance from that transmitter, transmit antenna to any person anywhere in the area, which could be on another building or who knows where near that transmitter. That's the rub. You very often don't have enough information to do an exemption calculation. Therefore, the only choice you have is do an evaluation for compliance of that transmitter. And you need to get that done by May 3rd of this year. Now, the power limit that we're talking about is the general population or uncontrolled exposure limit, which is 1 milliwatt per square centimeter. Keep in mind that that is not an instantaneous measurement. That's a measurement over a 30-minute time. So we're not talking about a person just walking in front of the antenna for an instant, which might happen if you're doing maintenance in the area. We're talking about someone who might be standing near that antenna for several minutes. And if that's the case, the commission wants you to have the power density 1 milliwatt per square centimeter or less, or take action that we'll talk about. In other words, you can have higher power density, but you have to take particular actions such as control the general population, put up signage, that sort of thing. If you never have energy greater than 1 milliwatt per square centimeter, you're home free. You really don't need to do anything. There are two limits that the commission talks about. They talk about occupational or controlled exposure limits. Those are limits that would apply for the RF area for people who know what they're doing, they're aware of the potential exposure, and can take mitigating action to protect themselves. What the commission is especially worried about is the general population or uncontrolled exposure. There will be transmitters out in the world that the general population could be exposed to, and they might not be aware of it. And they may not be aware of the things that they could do to mitigate the effects of that exposure. And so that's what the commission focuses on, the uncontrolled exposure limits and whether or not we're in compliance in those. And if we aren't, they give us particular actions that we need to take. There are 4 different categories of exposure that the commission talks about, and there are signage requirements for each one of those categories. In other words, signs that have to be posted in that area of exposure. Categories 1 really doesn't require you to do anything. If you're in category 1, the general population or uncontrolled exposure would be no greater than 1 milliwatt per square centimeter. If that's the case, you're home free. You don't have to do anything. You don't even have to put up any signs, although most people do. Category 2 is where the potential RF exposure is between the uncontrolled limit of 1 milliwatt per square centimeter and the controlled limit, which is 5 milliwatts per square centimeter. If you're falling in that area, you do have some nominal signage requirements, and that's not very difficult to do, but you have to be sure that you still have maintained the exposure limit to the general population below the Category 1 limit. Category 3 is where you are between the controlled exposure limit of 5 milliwatts per square centimeter and 10 times that, or 50 milliwatts per square centimeter. Now you're talking about having to take some action to control who can be in the area and where they can be in the area, and the signage requirements have increased. If you're beyond the 50 milliwatts per square centimeter limit, you've got additional signs that you need to put up and additional controls that you need to use to mitigate the exposure. These are the typical signs that you would be using for the various categories. The title, background color, and RF energy advisory symbols are mandatory on all of these. Also, you have to explain the RF source, behavior necessary to comply with exposure limits, and provide up-to-date contact information. And it may be that you will have to use multiple signs to accomplish this. RF transmitter operators, both licensed and unlicensed, are obligated to perform this RF emission level evaluation. They're also required to provide appropriate public safety protections and publish signage information. Now, we're not going to get into the safety precautions and signage requirements. Those require additional engineering and legal expertise that are really beyond the scope of this presentation. What we will focus on is doing the RF evaluation. That's something that everyone needs to do, and we're prepared to discuss that. I'll just point out as an aside comment that for existing licensees or existing transmitters, if you're unlicensed, you need to do the evaluation, but you don't need to file this information with the FCC. Now, when you apply for a new license or an extension of a license, you will have to file this with the FCC. But for the existing folks who are required to do the evaluation, you do it and then you just file it.
And George, if I can jump in just momentarily.
Yes.
This presentation focuses on existing licensees.
Yes, correct.
But the requirement applies, as George said at the beginning, to all licensees. So any new facilities would also be covered by this requirement. The reason we focused on existing licensees with our evaluation is simply because there are so many of them that the burden to conduct the evaluation was significant in the time before May 3rd of this year. But going forward, you will also need to conduct this evaluation for new facilities. And as George said, when you file new applications with the FCC or renewals, there will be a certification that you conducted this analysis.
Well, that's correct. Typically, I expect that certification will occur, will be done by the frequency coordinator. That will be another service that they will provide, but I'm speaking under an assumption here. I'm not a coordinator, so I'm only surmising that they will provide that calculation for you. But right now, you're obligated. You as the licensee are obligated to provide this calculation. Okay, well, there are currently over 400,000 fixed point-to-point licensed microwave systems, microwave transmitters in the United States today. That is a pile of transmitters, and they all have to be evaluated. Now, what do you do if you don't have time to inspect 400,000 transmitters? Well, I don't think any one person is going to be responsible for all of them, but you could be responsible for thousands. That is not unlikely. Not only that, currently, there's not an adequate method of demonstrating FCC compliance. The FCC's guidelines in Bulletin 65 are not particularly accurate, and they only apply to a parabolic antenna. They don't apply to the panel antennas used in unlicensed service. So we have provided a methodology that covers both both parabolic antennas and panel antennas. We're going to focus today on the parabolic antennas that are used in the Part 101 license service, but we also provide methodology for doing the evaluation for unlicensed transmitters. And I'll point out that the unlicensed transmitters, in my highly biased view, are probably the greatest risk in terms of RF or power density, because as you will see once you get into the calculations, that power density is not a function of frequency, it's a function of area of the antenna. And as the antennas get smaller and smaller, the RF energy is spread over a smaller and smaller area, which means that the power density for a given amount of power will go up, will increase as the size of the antenna is decreased. So we'll find that the antennas that we're dealing with typically are on the order of 3-foot antennas at 6 gigahertz and 1 or 2 foot antennas at 11 gigahertz or higher. Those are typically the antennas that kind of push the limits of the FCC's requirements. Now, this methodology information is available to anyone. I've listed the items here. I'm not going to go into each of these items other than just to describe in summary what they are. But this information is available to anyone who will email Seth at FWCC, and he will send you this information. This describes the evaluation that we made on all 400,000 Part 101 transmitters, and showing, with one exception, they're all compliant. We also give you evaluation details, which describe how we did the evaluation, and a numerical analysis, a spreadsheet that does the number crunching for us. You'll find that of use, because you can use that for your evaluation of your transmitters. If you open up the spreadsheet, the calculation methodologies are in there. The formulas are embedded in the cells, so you could just reuse those for your own purposes. We use 3 evaluation steps in our methodology. I call them step 1, step 2, and step 3. Those are described in the 3 appendices that I've listed here, which Seth can provide you. The third methodology is the detailed evaluation, and that may require near field information. And so the near field correction factors are in Appendix D1 and D2. Most cases you will not need that information. That's only when you're dealing with a person that's very, very close to the transmit antenna, and that's not very common, but it is available should you need it. We're going to be talking about near field power density of the typical transmitters. For licensed parabolic antennas, we're typically dealing with illumination efficiency or aperture efficiency of in the order of 50–55%. For the unlicensed transmitters, they usually use panel antennas that have an aperture efficiency of 100%. The side lobe performance of the unlicensed panel antennas is rather poor, but it's of no consequence to the unlicensed users. They're not interested in doing frequency coordination. They just want the most bang for the buck, and illumination efficiency of 100% gives them that. But nevertheless, we will focus on the parabolic antennas of Part 101. First thing we do is the simplest evaluation we can do. We evaluate the bore site power density of a transmitter. That is definitely the worst case power that a person could ever be subjected to near to the antenna. To do that, we need to determine the antenna diameter, or width if we're talking panel antennas, the antenna gain, composite power. Now there, it's got to be the entire power that's delivered to the antenna from both polarizations. And sometimes that can be a little challenging to get that information, but you want to know what is the total transmit power that appears at that antenna. You derive the antenna illumination efficiency. That's a required parameter. And then you calculate the antenna worst case bore site power. If the bore site power is less than or equal to 1 milliwatt per square centimeter, you're done. You've complied with the FCC's requirements uncategorically, and you need to take no further action other than file your calculation. Now, when we did the evaluation of the Part 101 licenses, we found that this cleared 80% of the Part 101 cases. So most people will pass based on this criteria. But let's suppose your bore site power density is a little higher than 1 milliwatt per square centimeter. Well, then we take advantage of the fact that the energy at the edge of a parabolic antenna is 10 dB down relative to the bore site energy. And we also point out that we engineer these antennas for very high availability, typically on the order of annual outages of no greater than 3 minutes per direction. And so we're going to make sure when we engineer these systems that nobody can walk in front of the antenna and degrade it, especially since we're talking about power densities averaged over as much as 30 minutes. If somebody walks in front of an antenna, especially a 1 foot or 2 foot antenna, which is typically what we're dealing with, you're going to knock that path down. So we're going to be sure when we engineer our paths that this can't happen. So if we're confident that we meet that criterion, we're confident that no casual person can be in front of the antenna, then we're done. As long as the bore site, as long as the bore site power is no greater than 10 milliwatts per square centimeter, then we can be confident that the power at the edge of the parabolic antenna will not be any greater than 1 milliwatt per square centimeter. Our only obligation here is that we've placed the antenna in such a way that the general population cannot get in front of the antenna. Now, for these cases, if we include the step 2 evaluation, we cleared 99.9% of the licensed Part 101 cases. So it would be very unusual for a Part 101 transmitter to exceed 10 milliwatts per square centimeter bore site. If the bore site transmit power exceeds 10 milliwatts per square centimeter, then we're going to have to do a detailed evaluation. Now we've got to figure out what is the worst case distance R between the transmit antenna and a casual person who might be just wandering around that particular transmit antenna. To do this, we're going to need some detailed information, and that's why we try to avoid using step 3 if we can. We try to pass a transmit antenna using step 1 or step 2 if we can, because that doesn't require us to know much information about the site. However, if we do need to do an evaluation, then we'll go through the step 3 process, and this is the most detailed, and you could in fact use the step 3 for any case, but we try to restrict it to just the cases that don't pass step 1 or step 2. Well, first thing you do is you determine the worst case distance R between the antenna and a casual human. You can usually do this by using Google Earth and a knowledge of the antenna height above ground level. Most of the antennas we're talking about are on towers that are out in rural areas, and it's pretty clear that the distance R will be the distance directly below the antenna. That's typically the case, but you really have to evaluate that on a site-by-site basis. Then you determine the antenna rejection value relative to bore site along the worst case exposure path. Typically, you can use the FCC minimum values for B2 antennas, since we know that for licensed service, you have to be using an antenna that complies with the FCC's Category A or Category B parameters. We can usually use a category B2, which is the least restrictive antenna pattern, and use that as the rejection value. And usually that's adequate to show compliance. So we don't have to go to the complication of actually finding the rejection values for the specific antenna of consideration. Then we need to get the antenna diameter and antenna gain and determine the composite power delivered to the antenna. We also may have to add a near field correction factor if the human could be very close to the antenna. And then we perform the calculations in accordance with Appendix C. And if we do that and find that the calculated power density at the worst case human location is less than or equal to 1 milliwatt per square centimeter, we're done. If we don't, then you've got to resort to more detailed mitigation measures, such as restricting people in that location.
And George, I know you'd mentioned I know that you'd mentioned that most of the locations that were subject to step 3 were rural transmitters that were on towers, but can you talk through just one or two of the other examples of evaluations that were conducted under step 3?
Okay, yeah. As I mentioned, most of the antennas were in rural areas where the transmitter was on top of a tower, and no one's going to get close to that antenna under normal circumstances. But we did have a couple of cases where we had antennas on top of silos. We had a couple of cases where we had antennas on rooftops. And those are interesting because you have to evaluate nearby buildings. So we went to Google Earth and we did that and figured out what the worst case distance R would be between the transmitter and the casual human. So we had a case where there was an antenna on a water tower. Again, most people are not on water towers, so we didn't have to worry about that. So there were a few urban areas that an antenna could be on. Primarily the most challenging case where we had to evaluate transmit power was on rooftops. On rooftops, you have to make sure that you don't have a nearby building where there's somebody out on the balcony or something like that on the nearby building. Fortunately, for all the cases that we evaluated, the rooftops were in industrial areas where typically the building that the transmitter was on was higher than any of the other buildings, and the other buildings were all enclosed. There was, they were industrial buildings, warehouses, yards of various sorts. So the urban areas were interesting and required a little more work to do some clearance to make sure what the distance was.
And I'll just add, I think for everyone on the webinar or anyone watching, that's really the area that the FCC, I think, is going to be concerned about. There is at least potential that rooftop antennas could have access in an urban area for a rooftop bar that would be at the same building. Of course, the bar wouldn't be immediately adjacent to the antenna necessarily, but I think those are the types of situations that George is describing where the FCC is going to have the most concern, and where if you've got facilities in that type of setting, if you're not cleared by step 1 and step 2, that you're really going to need to pay close attention to the signage requirements and whether or not it's possible for anybody to access that area. But as George said, that's not what we found in our evaluation.
Yeah, we were fortunate that first of all, there were only 100 of the over 400,000 transmitters. There were only 196 that had bore site power densities greater than 10 milliwatts per square centimeter. So the task was much smaller than the overall population. And what we found was that in virtually every case, the transmit antennas were either on the in rural areas on towers, or they were in urban areas, but where you were working in industrial areas, you might have a rooftop, but the rooftop would be in an industrial building, where the assumption would be that there's no reason for the casual observer, the casual human, to be on that rooftop. And so we assume that you will have controlled access of that. What, of course, is the main concern is what about the buildings near that rooftop, and that's what we paid the most attention to. Okay, we did an evaluation of all 400,000 licensed Part 101 transmitters, and we found that all of them complied with the FCC's requirement, with one exception. There was one station that had 8 RF channels with an antenna that was 7 feet above ground level. That was just too close to, and too much power to clear that case. That was in a VRBO in the U.S. Virgin Islands, not in the continental U.S. So there was no Part 101 transmitter in the continental U.S. that did not pass the FCC requirements. So we're confident when you do an evaluation of your transmitter, you will clear. But you still are obligated to do that evaluation. Bottom line is, you usually can do an evaluation to show compliance without a whole lot of work. An awful lot of it can be done on the desktop without actually doing detailed evaluation of the transmit location. And that's important because you're dealing with a lot of transmitters. As long as you have site coordinates and other details, you can do the FCC RF evaluation without extensive site research. So put May 3rd on your calendar, grab your transmit antenna and transmitter information, and get your evaluation done. Now, I'll entertain questions. Does anybody have any questions on this process?
And everybody was muted during the presentation, but you should be able to unmute yourself. If that's a problem, I can also unmute people.
George, this is Joseph Sandri, NSMA. Thanks for doing this, and thank you, Seth, for FWCC's hosting systems. And this is obviously very valuable to the industry. A few quick thoughts. One is, everyone at FWCC and of course at NSMA is invited to a panel that'll occur May 15 or 16 on RF exposure at NSMA's 38th annual meeting at the National Press Club in Washington, D.C. So if there's further thoughts on this or related issues, and regarding related and semi-related issues, I don't know, George, maybe you want to speak a little bit to the unlicensed systems that are out there, and how, if folks encounter those or also have them in their network, or if folks encounter a complex environment where there's a fixed wireless, Part 101 transmitter that's compliant, but they're also on a roof with a whole cluster of other things. Do you have any thoughts or guidance about any of that?
Well, a couple of things. First of all, I want to point out, I forgot to mention, that we have already taken this analysis to the FCC. We took it to a group at OET and described what we did, and they seem to be satisfied with our methodology, our approach, and our evaluation. So we've had at least one pass with the FCC, and they seem to be happy with this methodology. Now, having said that, we haven't talked much, and nor have we pushed this issue with the FCC, but they also authorize unlicensed transmitters. And those unlicensed transmitters often use very small antennas, usually panel antennas, and those can have relatively high power density, and those need to be evaluated. And those are my worst concern. Anytime you have an unlicensed transmitter, you are obligated to evaluate the power density in front of that transmit antenna, And if it's a small antenna, that could be a significant issue. You know, small transmit antennas in the microwave range are potentials for very high power levels.
And let me just add, Joe, that this evaluation, which, as George mentioned, has been shared with the FCC, is a tool for licensees to use. And so I don't want anyone to take the impression from this presentation that if you've got a mixed transmit site, as Joe was referencing, that there wouldn't be a need to put signage up to control access to the site. There are other situations that may require you to evaluate your site, but this is a tool to specifically evaluate your Part 101 licenses, and then you will need to consider consulting with counsel and engineering experts within your organization, or consulting engineers who can help you evaluate a site that might be more complex, as Joe was mentioning.
Right. We do give you the methodology for evaluating the power density of panel antennas also, but we don't address the area of how do you control that area if you don't meet the FCC's requirements, and specifically what are the signage requirements for that site. I'll leave that to legal counsel on that. I have an opinion, but I'm not qualified to offer an opinion on that.
Yeah. That's very helpful. I think, just currently advancing the state of the art, the tools for assessing, and, just continually pressing forward to provide the FCC with different looks at how we're working as an industry to comply, and giving them a good opportunity to review. So, that's all very helpful, I think, to everyone involved. So thank you.
Well, I would ask everybody to ask Seth for the detailed calculations and methodologies, because until you've taken a look at those, it's probably a little difficult to ask meaningful questions, because you don't know what the details are. But anyway, we've got lots of details. So if you'd like to understand how to perform these calculations, we have descriptions on how to do that, but as you would imagine, they're a little detailed. Okay, do we have
any other questions? And as I said at the beginning, this presentation or a recording of it will be available online. If you have any questions, feel free to follow up with Joe or George or myself. Our email addresses are there on the question slide. And as George also said, the underlying calculation material will also be available both online, and I'm happy to email it to anybody who reaches out. If there are no further questions, thank you very much, everybody, for joining, and enjoy the rest of your day.
Thank you.